Hello, Chem 2 students. Mr. Keister here with you again today. This is the lesson for Wednesday, November 11th, 2020, which is our scheduled 58th day of school for the fall semester. Always keep in mind, though, that the dates could change for a variety of reasons, but the lessons and the order that those lessons are presented will remain the same regardless. Before I take a look here at the schedule for today, our due nows, I would want to recognize that November 11th is Veterans Day, right? It's our official holiday. And it would go without saying, I would be remiss if I did not mention how proud and honored I am of all the veterans who have served our country, who are currently serving our country, and who have in the past. My grandfather served in the Army in World War II in the Pacific, and my son-in-law, ex-son-in-law, but I still consider him my son-in-law. He also served in Afghanistan, and so I certainly want to recognize them personally for their sacrifices, and certainly all those other veterans around the world who have served around the world for our country to help keep us free and enjoy the way of life that we have here that many others wish they had but do not. And so to them I say thank you, and we are proud of you, and we will remain proud of you always. So let's get on to today's lesson. Today's due nows. So today we're going to pick up binary and molecular compounds and nomenclature of those, page 78. Your homework for today was to complete the nomenclature ionic compound review assignment. That is due now. So if you're here in class, that should already be on my desk. If you're at home, you need to submit that to me electronically at the beginning of your regularly scheduled class period. So make sure you do that. Don't be late, okay? You could, of course, check your answer keys first. If you're here in school, you can do that on the board. If you're at home, you can check with the answer keys page in Canvas. So today we're going to continue with Unit 4.2, which is about chemical nomenclature. Today we're going to look at binary molecular compounds, which are formed from covalent bonding. We've been looking at ionic compounds the last couple of days. Today we're going to switch to compounds that are formed from covalent bonding. You'll have an assignment over this that is due today by the end of class. All right. Today's lesson is quite short, and the assignment is equally short. It won't take you long, I promise. You'll be able to check your answers with the key once you've finished your assignment and shown it to me if you so desire. And FYI, we have an exam coming. Unit 4.2 exam will be this coming Monday, November 16th. All right, this coming Monday, November 16th. So just FYI on that. I'll give you more info on that in the coming days. So let me flip the board to today's lesson. And here we go. So binary molecular compounds are composed of two nonmetals bonded together covalently, or between a nonmetal and hydrogen. Remember, hydrogen has a very high electronegativity, even though it's in group 1A, and we've said this before, hydrogen is not an alkali metal, all right? It is a nonmetal, of course, it's a gas, couldn't be a metal, all right? And with its high electronegativity due to the fact that it only has one electron, and it wants to get that second electron and be like helium, where its 1s orbital is completely full. With hydrogen's high electronegativity, normally it bonds covalently with other nonmetals. All right, and so and also note that hydrogen will appear at the back of a compound. In other words, it will be listed second in a binary molecular compound. You're also going to find hydrogen in acids, which we're going to go over tomorrow. And in that case, the hydrogen appears first in the compound. All right. So today, if we're involving hydrogen, it will appear at the end or on the back side of the compound. So remember that. So recall that these compounds are molecules. They are not composed of ions. There are no positive and negative charges associated with these compounds. They're neutral atoms that have bonded covalently. So, which means that balancing ionic charges is not done in writing their formula, right? It's not done. Don't need to. Nonmetals often combine with each other in more than one way, all right? And each compound formed has different physical and chemical properties. For instance, carbon and oxygen combine in two different ways. They can form CO2, which is through normal covalent bonding. If you remember, CO2 has two double bonds in it. And then you have carbon monoxide, CO, which is formed from coordinate covalent bonding. All right, coordinate covalent bonding. Same, they got the two others here down here, same situation. PCl3 is formed from normal covalent bonding. And PCl5, remember, this was an expanded octet. We talked about that, drew it. Actually, you made the molecule back in the lab in 4.1. Okay, PCl, lab 4.1. PCl5, an expanded octet. So, if you have multiple compounds that contain the same elements, how do you tell them apart? How do you distinguish their names? How do you distinguish their names if their formulas are different? Well, I got a one-word answer to that, and the answer is prefixes. All right, prefixes. So, when naming molecular compounds, the first element's name is normal. All right, normal. The second element's name always ends in IDE. Always. All right. So first name normal, second name IDE. Prefixes are used in both elements' names, first one and the second one, to signify how many of each atom is found in the molecule. So here is our list of prefixes. You'll need to memorize these. You probably remember a lot of these. You probably heard them before. Back to Chem 1, I know you did. So 1 is mono, all right, 2 di, 3 tri, 4 tetra, 5 penta, all right. Some of these sound familiar too because they're used in some of our molecular shape names, remember? 6 is hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. There are others beyond 10, but we're only going to concern ourselves with these, all right? So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Prefixes are used in both elements' names to signify how many of each atom is found in the molecule. As I go to the next page, you'll note that there is one exception to that rule, and only one, all right? And that is this. When there is only one atom of the first element, all right? When there's only one atom of the first element, we drop the mono. We just name the element. That's it. Okay? Just name it. All right? So, let's look at some examples there. So, CO. Okay, so there's one C and one O. The prefix for one is mono. But here again, with only one of the first element, we leave the mono off. So, it's instead of monocarbon, it's just carbon. But now we do use the mono for the last one. Remember, second element, first name's normal, second name ends IDE. So this would be monoxide. Actually, it's monooxide, but we drop the 1 O. Right? So it's carbon monoxide. As compared to the second one, which is carbon, I'm sure you recognize this, dioxide. With 2 O's in there, prefix is di, ends in IDE, so dioxide. BCl3, well, there's only one boron, so we leave the mono off. And then 3 is tri, again, IDE ending, so trifluoride. Okay. The next one, Cl2O7. Cl2, okay, 2 is di. Remember, the first name's normal, so it's dichlorine. All right, not dichloride, but dichlorine, first name normal. And then 7 is hepta oxide. All right, hepta oxide. Now, in some literature, some reference books, you will also see heptoxide, where when you have that AO together, like heptoxide, that you can drop the A. All right, you can drop the A. Now, I've seen it written both ways, heptoxide and heptoxide. As far as I'm concerned, they're both correct. With mastering, you never know how they are. If I recall, I think they accept both names as well. If not, why don't you try when you get to that assignment mastering when we assign it? I would go with the A off of it first, like hept oxide. Try that first, see if it takes it. If it doesn't, it's probably not going to deduct anything, and throw the A in there. I think it takes it both ways, but I'm not 100% sure about that. Next one, SF6. That was that expanded octet molecule we built last unit. So that would be called sulfur what? 6 is hexafluoride. So SF6 is sulfur hexafluoride. N2O5, dinitrogen. Remember, first name's normal. Dinitrogen, and then 5 is penta. So penta oxide. Here again, with that AO connected, you can drop the A, and it would also be correct to say just pent oxide. So dinitrogen pentoxide or dinitrogen pentaoxide. I don't care how you write it. It's fine for me either way. Okay? All right. Next, when writing formulas for molecular compounds. All right, there's no balancing charges here, so it's much simpler. All you do is look at the name. The prefixes will tell you how many of each type of atom is in there. All right, so this is really simplified. All right. So we just look at the name. All right. So sulfur dioxide. If it just says sulfur, how many sulfurs are there? 1. Dioxide, di is 2, so it would be SO2. Right? Of course, you don't need the 1, just write the symbol tells us there's 1. Sulfur trioxide, well, again, 1 sulfur, but now there's 3 oxygens, so SO3 would be sulfur trioxide. Do not mistake that with the sulfide ion. All right, sulfide is SO3 negative 2. All right, that's different. That's a polyatomic ion. This is the molecular compound SO3, sulfur trioxide. Now they're related. All right, they're related. Just to give you a little background there, sulfur trioxide is fairly unstable because 2 out of those 3 oxygens are missing an 8th valence electron, and so when they each gain an electron, that's how the sulfide ion is formed. Sulfide ion is more stable than sulfur trioxide. Dinitrogen, 2 nitrogens. Tetraoxide or tetroxide, 4 oxygens, N2O4. See how quickly this is going? Iodine, only 1 there. Heptafluoride would be 7, IF7. Tetraphosphorus, 4. Decaoxide or decoxide, 10, E4O10. And then I said the last, how about dihydrogen monoxide? 2 hydrogens, 1 oxygen, H. Anybody recognize dihydrogen monoxide? Yeah. Got a common name for that. Water. All right, water. Funny story about dihydrogen monoxide. You can Google this if you want. You'll see several things. But I think the first one was maybe back in the 80s or so, long before the internet. I think it was out in California. Some smart alecky kid, I think he was a college student, called into a local radio station and said, "This is a terrorist threat. Our city's water supply has been poisoned with dihydrogen monoxide." All right, really? Poisoned with water? I don't think that's poison. Well, anyway, I think the radio DJ either didn't take chemistry or he slept through that lesson, didn't pay much attention. He didn't know what dihydrogen monoxide was. He thought it was some poisonous chemical. So they went out before doing any checking, went out and put out an alert to everyone not to drink the water. Of course, then when somebody called in later and said, hey, buddy, dihydrogen monoxide is water. You've been pranked. Felt kind of silly, I would assume. But you can Google that. You'll find a story like that on there, similar to other stories that people have tried that. But we all know, of course, that dihydrogen monoxide is just water. All right? So that's the end of today's lesson. I told you it's a short one. Your assignment is equally short. So get going on that, folks. That is due today by the end of class. I'm collecting that today. Shouldn't take you long. So I think that's all I got for today. So until next time, this is Mr. Keister signing off. Take care, everyone. Stay safe. Keep working hard. Stay focused. I'll catch you next time.